what property of a wave determines the color you see? It is wavelength. So number one, what determines the color you see? The color you see is determined by the wavelength of the light. So, red has a specific wavelength, green has a specific wavelength, blue, orange, all those things. So, whatever you see, like something looking orange or looking blue or looking red, that's because that's the wavelength you're seeing from the object. Okay? Just like we can see visible light because it has a very specific wavelength. We can't see infrared because its wavelength is too large. We can't see ultraviolet because its wavelength is too small. Something that is blue, like this globe, is going to produce the blue wavelength of light. And all of them have specific values. You don't need to know the specific values. You should know the order. Red has the longest wavelengths. I think it's about 650 nanometers, and blue violet has the shortest wavelength. It's around 300 nanometers or so. So the property that defines it the best is wavelength. So there you go, number one already done. So what are the primary colors? All right, someone tell me what the primary colors are. Red, yellow, blue. Congratulations, you have all been lied to by your art teachers. Those are not the primary colors. So let's talk about. I love this. This like you guys have spent like the last 12 years being lied to. You realize all of a sudden you're like, what? Anyway, so it depends on if you're talking about pigments or talking about light. Since light is where everything comes from, that's the most important one. For pigments, it actually is magenta, cyan, and yellow. If you've ever looked at a newspaper, in like the bottom corner, there's like a yellow, magenta, and a cyan box. It's because the way they print newspapers is they run the newspaper through 3 times. They print it once in yellow, once in cyan, once in magenta. When you mix them together, you get black. They do run a black coat over the top of it, but that's the basic way. But light is where everything comes from. And in fact, light is also where the pigments come from. And the primary colors are red, blue, green. Those are the primary colors. Red, blue, green. And you might be saying, oh, well, Mr. B, you literally just said the primary colors are yellow, magenta, and cyan. Well, okay. Magenta is red and blue with no green. So magenta is green, but it's green pulled out, not green added. Okay? Yellow is green and red, but no blue. So it's blue pulled out instead of blue added. Pigments are called color subtractive. This is not important. But pigments are called color subtractive. So the primary colors are red, blue, and green, but it's red pulled out, blue pulled out, green pulled out. Light is called color additive, so it's red added, blue added, green added. Yes?
Is art red, blue, and green like the same thing as like colors of colorful lights that you can change the color of the thing, and they're called like the RGB lights?
Mm-hmm. Yep. And we're going to look at that here a little bit too. Yes?
When you say blue, are we talking about blue there?
You're talking about like blue or indigo?
Yeah.
We're talking about blue. So like this color blue.
Okay.
Yeah. It's not like blue. It's not like blue. All right. Let me get these guys set up here. Really? Not going to turn this morning? It was too cold to turn? So we'll go. We'll see if this won't work large scale on my projector. All right. So primary colors: red, blue, and green. So I have up here 3 lights. I have a red light, a blue light, and a green light. And I'm going to kind of just show that to you. So I have the primary colors. Do you mind turning those lines up. And let me get rid of this. Let's see. Are we working today? No. Great. No. Haha. Good. Okay. So. So I have here blue, red, green. Okay? So, and I'll turn on the light so you can answer the questions here in a little bit. So the first question here, so what determines the color of a light? So the color of light is determined by what color it reflects. Oh, wait, hold on. Just kidding. No, yeah. Number 3. The color of an object is determined by what color it reflects. I'm sure. So, I got 3 colors up here. Green. Actually, let's do it here in the middle of the board. Green. Red. And blue. And yes, I realize I wrote on my whiteboard in Sharpie.
Oh, no.
Okay, so I wrote hi in 3 different colors. I wrote it in green, red, and blue. So why do I see the different colors I see? Well, I see green because it's reflecting green. I see red because it's reflecting red. I see blue because it's reflecting blue. Every other color works like this too. So why do I see purple? I see purple because it's reflecting purple. Now, purple is actually a combination of red, blue, and green. But from a simple perspective, in other words, what do you need to know for the final? Objects are the color that they reflect. So an object that's yellow reflects yellow, purple reflects purple, and so on and so forth. Okay. So I'm going to kind of show you that here in a second. So what determines the object of a color? The color or the color of an object, the color it reflects. So what is white light? White light is red, blue, and green combined. So I'm going to put all these colors on. Now this is, first of all, this is not going to be perfect. And the reason is they're not perfect red, blue, and green lights. They're also fairly far away from the board. And they're not on top of each other. They're off to the side a little bit. So if I turn them all on here, you'll see that my board is relatively whitish. Again, I'm pretty far away. It's kind of hard to see. But you'll see in a second there is a very distinct difference between this and the other colors. So first of all, it's a little hard to see, but you can still kind of see the colors. That's still green, that's still red, that's still bluish, that's still purplish. You can still see the colors here. So this is going to be the last one, which is what happens to the colors if you only shine one color of light on it. So what happens to red if I only shine red? Well, it looks red. In fact, it's almost impossible to see. And the reason is the whole whiteboard is red now. And so the red board and the red writing basically blend in together. But you can see the other highs because the other highs do not reflect red. So they look black because they're not reflecting their color. So all you see is that there's something there, but you can't see the color reflected back. Now look what happens to red if I change it to blue. Now the blue is basically gone, the green to an extent, and the red and the purple are still there. Okay? Same thing here. Turn off the blue, turn on the green. The green you basically can't see, the blue to an extent, and you can see the red and the purple. So the thing I want to make sure you understand is that things will reflect the color that they are. Okay? So things that are red will reflect red light. If there's no red light, the object looks black. If there's no red light, the object looks black. If there's only blue and green light, you can see even if I just turn on the blue and the green, I still can't see the color of red. It's only when I turn the red light on that I can see it. And that's the same with all the other colors. If I turn off the blue, okay, then the blue light starts looking a little black. Again, my blue and my green aren't perfect color lights, nor are they perfect color markers. But that kind of gives you an idea behind these. So again, the color you're going to see is dependent upon what color is reflected back. So kind of fun to look at. And you can see where all these colors come from too. Here, let's turn the. Oh, there we go. That's much closer to light. There we go. So here's your primary colors in paint. So here's so red and blue together makes magenta. Red and green together makes yellow. And blue and green together makes cyan. So those are the actual primary colors for paint because cyan is just no red. And red's a primary color. All right. Any questions on the color mixing stuff? So number 5, why does red look black if you show only green or blue light on it? There's no red to reflect.